Yes, good morning students. So in the previous video we discussed about the fourth module. We completed the fourth module. There we discussed about the different types of A to D converter, D to A converters, and rectifiers, precision full wave and half wave rectifier circuits we discussed, and some of the applications of the same. So in the fourth module, so we'll discuss about the phase locked loop. Fourth module is the phase locked loop. So the presentation of this module will be flows as per the content here. So first we'll have some of the introduction to the what exactly PLL is, and then we'll discuss the block diagram representation, then phase detect, each block of the PLL will discuss, and then we'll discuss pin configurations or pin diagram of your PLL, then characteristics of PLL, some of the applications of the phase locked loop. Okay, so that is the content, or that is what that is how the presentation will move. Okay, so now let me start with the introduction of phase locked loop. So phase locked loop is, once again, it is a closed loop system. So it is also an integrated circuit ICs. So it's a closed loop system. So phase locked loop is basically closed loop system. So so it is application. So the application of this is to lock the output frequency and phase of the input signal. So it will lock output frequency of the input signal. That is the application of your phase locked loop. Okay, so this phase locked loop is also used in the communication circuits in two different ways. So it is not only restricted to lock the output frequency, but also it is used in some communication circuit. So that is for demodulation applications and synchronization of the signal. So that is the applications of your phase locked loop system. So this principle of PLL is used in the applications such as the frequency FM modulation, okay, frequency modulation, and frequency shift keying demodulation. That is it is used in the FSK demodulation, and motor speed control, and frequency multiplication, and frequency division, and some other applications. So it is, once again, it is used in the FM demodulations. So then it is used in the frequency shift keying demodulation, then motor shift controlling, frequency multiplications, and frequency divisions. So these are the some other applications of your phase locked loop system. It is basically a closed loop system, closed loop integrated circuit IC. Okay, now we'll discuss about the block diagram of a phase locked loop. So block diagram, so this block diagram of PLL consisting of three important blocks, that is phase detector, low pass filter, and voltage controlled oscillator, VOC. Okay, so it is why I said it's a closed loop system. The output is fed back to the input. Here the system is a closed loop system, it is not a open loop system. So PLL IC is a closed loop functions. Okay, next we'll discuss about one by one what exactly phase detector is, and what exactly low pass filter is, and what exactly the voltage controlled oscillator is. Okay, now first we'll start about the phase detector. So phase detector, there are various types of the phase detectors we can use. So out of that I've listed here some of the phase detectors. So it may be of analog type, you can use the phase detector. It may be of analog type or digital type. Even sometimes flip-flop is also used to detect the phase of the signals. Okay, so these three are the different types of phase detectors here. Okay, the two input the phase detector consisting of two inputs, or it may be also constructed using the comparators. So the two inputs is, once again, that's the input voltage, that is at the frequency of input frequency, and the feedback voltage from the voltage controlled oscillator at the frequency of the F0, that is output frequency. So that is the phase detector. It consists, it may be a comparator, it may be any voltage controlled oscillator, anything. So it consisting of two inputs, that is one is at the Vi at the frequency of Fi, and another is at the V0 at the frequency of F0. Okay, that is the phase detector. So this phase detector compares these two signals, that is input signals and the feedback signals. So these two compares the input signals and feedback signals and produces the DC output voltage VE. Okay, DC output voltage is the output wave from the phase detector, which is proportional to the phase difference between the input and output frequency. So the DC output voltage which is produced from the phase detector, which is proportional to the difference of phase between input and output frequency. Then the output voltage VE of this phase detector is called as a error voltage. Okay, so this error voltage is in turn applied to the low pass filter. So error voltage from the phase detector is applied to the low pass filter. Okay, then this low pass filter what exactly performs? So this low pass filter, as you already discussed, the what exactly filter performs, so in the second module. So this low pass filters filtrate the unwanted portion of the frequency here and allows only the required frequency range. Okay, so that is what the function of your low pass filter. So low pass filter, whatever, it will removes the higher frequencies noises. So low pass filter is allows only low frequency signals and block the high frequency signals. These low pass filters removes the high frequencies noise present in the phase detector output, and it produces the ripple free DC level. High frequency noise signal it is completely eliminates, and ripple free output is produced from the this low pass filter. Okay, so this DC level is once again amplified into adequate level, and it is applied to the voltage controlled oscillator. So output of this low pass filter is applied to the voltage controlled oscillator. So this DC amplifier output is called as a control voltage VC. So initially the phase detector output is error voltage, then the low pass filter output voltage is control voltage VC. So this is the function of low pass filter. Next is the voltage controlled oscillator. Voltage controlled oscillator is another block of your phase locked loop system. So this voltage controlled oscillator, that is VC, which is applied to the input of VCO. The control voltage from the your filter is applied to the VCO, that is voltage controlled oscillator. The output frequency of this oscillator is directly proportional to the DC voltage VC. The output frequency of this oscillator will be proportional to the DC voltage, that is control voltage, right? That is what. Then VCO, that is the voltage controlled oscillator, frequency F0 is compared with the input frequency Fi. In this VCO, what happens is the output voltage F0, the output frequency F0 is compared with the input frequency Fi, okay, by the phase detector. Okay, and then it is adjusted continuously according to the required range. Okay, then frequency is adjusted here. Voltage controlled oscillator, the frequency is adjusted to the required value. The output frequency is continuously adjusted, which is equal to the input frequency Fi. Okay, that is the function of voltage controlled oscillator. So it is completes the block diagram. It consisting of three blocks. That is, first one is phase detector, low pass filter, and voltage controlled oscillator. So phase detector, which will compare the two signals, that is input signals and the reference voltage, sorry, not reference, the input signal and the feedback voltage, and produces the DC output. So that DC output is called as a error voltage. That error voltage is passed to the low pass filter. Okay, then that low pass filter will filter the higher frequency noise signals and allows only the low pass frequency signals to the output side. So the output of this low pass filter is passed to the voltage controlled oscillator, that is VCO, voltage controlled oscillator. So where what happens, it is adjust the frequency of the signal. Okay, then it is once again the output of this VOC is fed back to the input, and the cycle of the process will be repeating. So this is the block diagram explanation of a next is PLL IC. We'll discuss about pin configuration of a phase lock loop IC, that is 565. So it's a 14 pin IC. So the supply requirements are +1 and the pin number 1 and pin number 10 are the positive, negative and the positive supplies respectively. So pin number 1 is used to supply the negative supply, and pin number 10 is used to supply the positive one. Okay, so and pin number 11 to pin number 14 are not connected. As I said, all the ICs are designed with some standard packages. Because of that, they're chosen. So there is no connections for all these pins. Okay, so then pin number 9, 8 and 9s are used for the external capacitors for voltage controlled oscillators. So pin number 9 is for external capacitor for VOC, and pin number 8 is for the external resistance for the voltage controlled oscillators, and pin number 2 is input pin, pin number 3 is also input pin. Okay, so VOC output we have to observe from the pin number 4 here. Okay, so then phase comparator voltage controlled oscillator output is pin number 5. Then reference voltage is applied to pin number 6, and a demodulated output, okay, if you want to demodulated output you can get it from the pin number 7. So this is the pin configuration. It's a 14 pin, so pin number 1 to pin numbers 14s are explained here. 1 is for negative supply, 2 3 are for the input voltage, and 4 5 for the output, and 6 is for the reference output, and 7 is for the demodulated output, and 8 is for external resistor connection for the VOC, and 9 is for external capacitor connection for the VOC, 10 is for the positive supply voltage, and pin number 11 to 14s are for the not connected terminals. They don't have any connections. Okay, so this is about the pin configuration of this. The applications and the characteristics of this PVLL we will take up in the next class, right? Thank you.